So welcome to another session of Everyday Mathematics. Today's problem is a part two of what we did yesterday, problem number 12 of the MIT 2024 Integration B regular season. And the problem was the integration from x equals to 1 to x equals to 3 of 1 plus 1 plus dot 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 over x plus dot dot over x plus 1 plus dot dot over x plus dot dot. So this is a recursive problem. And there's a third method by which this can be solved. And this method was brought to our attention by a subscriber, which is first of all, obviously equating u to our integrand, 1 plus whatever is under the integration sign. And as we know, that upper part here is also equal to u, and this lower part also is equal to u, so that we have the expression u plus u equals to 1 plus u over x plus u. Multiplying both sides by x plus u, we have ux plus u squared equals to 1 plus u. And so making x the subject would first of all entail subtracting u squared from both sides. So we have x equals to 1 plus u minus u squared. Divide across by u, we get that x equals to 1 over u plus 1 minus u. Now that means that dx du is equals to negative 1 minus u squared minus 1. And so we can substitute dx with negative 1 over u squared minus 1 du. Now, since ux plus u squared is equals to 1 plus u, when x equals to 1, that means that u plus u squared equals to 1 plus u, and therefore u squared minus 1 is equals to 0 by subtracting both sides by u, and that means that u minus 1 times u plus 1 equals to 0, therefore u equals to 1 or negative 1. And since we saw from our expression that u must be positive, it means that u equals to 1. When x equals to 3, means that 3u plus u squared is equals to 1 plus u, and therefore u squared plus 2u minus 1 equals to 0. Using the quadratic formula, u equals negative 2 plus minus square root of 4 plus 4 over 2, and therefore u equals to negative 1 plus or minus square root of 2. And again, we know that within the interval of integration, u must be positive, so u equals to square root of 2 minus 1. And so our integral is therefore the same as, in place of 1, we have 1. In place of 3, we have square root of 2 minus 1. In place of the integrand, we have u. In place of dx, we have negative 1 over u squared minus 1 du. And you can pull out the negatives and then flip this limits so that we have the integral from root 2 minus 1 over to u equals to 1 of u times 1 over u squared plus 1. And so multiplying u across means that we have the integral of 1 over u plus u. And the integration of 1 over u is a natural logarithm of u. The integration of u is u squared over 2. And then we apply the limits. So log u, applying the limits, we have log 1 minus log of square root of 2 minus 1. And then here we have 1 over 2, 1 squared over 2 minus root 2 minus 1 squared over 2. And so using the rules of logarithms, we have here natural logarithm of 1 over root 2 minus 1, plus combining these two, since we have a common denominator here, we have 1 minus root 2 minus 1 squared over 2. And so multiplying both the denominator and numerator with square root of 2 plus 1, we have log of square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1. And then here when we multiply or we expand this expression, we have 1 minus 2 root 2 plus 1. This plus this is 3. So we have here, first of all, root 2 plus 1 under the log, function, and then 2 squared minus 1. So because this is the multiplication of the difference and the sum, so this is 2 minus 1, which is 1. So we have natural logarithm of root 2 plus 1. And then here 1 minus 3 is negative 2. Negative, negative, we have positive. So we have 2 root 2. And this 2 and 2, 2 and 2 cancel. So eventually we have, since 2 minus 1 is 1, we have natural logarithm of square root of 2 plus 1 minus 1 plus root 2. And this here, my friends, is the answer that was provided. This is a much simpler method, obviously. We really thank our wonderful subscriber. We may not have been able to do it without that suggestion. But all the same, we are very thankful to our subscriber for bringing that to our attention. The subscriber is at Apple, Alvin 9167. Definitely at Apple Alvin 9167. Many thanks. And this obviously is the kind of interaction that we do encourage. So until next time, bye bye. Keep your suggestions coming, and we promise to feature them. Bye bye.